Okay, we're recording again. Okay, let's go over this practice test review, okay, for the unit for DCA, okay. Now, in number 1, there the parallelogram is not drawn for you, so let's go ahead and draw that for you. Okay. So what happened to my... looking for my... oh, there it is. Find my ruler. It got stuck under my notebook. All right, so if I was going to draw a parallelogram, if you had to draw one, it's easy just to take a ruler. And they usually just draw it, so they try to make it look like the opposite sides are parallel. It's just a sketch. It doesn't have to be perfect. Like I said, I'll have rulers available if you have to draw it in yourself. They might actually have it already drawn on the test for you. I don't know. But it says it's parallelogram, and it's named ABCD. So if you have to draw it yourself, the way to do it is you pick one vertex, pick one corner, and put an A there. The first letter is an A. You have to go in the order they have the letters. They do have them alphabetical. They go A, B, C, D. So you will either want to start at A and go to each corner by going clockwise or by going counterclockwise. I'm going to go clockwise. So if this is A, this would be B, this is C, and that's D. So that would be parallelogram ABCD if I had to draw it in. Now, it says diagonal AC is drawn, so draw that diagonal from A to C, draw that in. Okay, and now it's done. Alrighty, so it says which statement must always be true. So we're looking at what will always be true here, okay? So if it's not a property we talked about when we talked about the 6 properties of parallelograms, then it can't always be true, and you're not going to pick that one. You're going to pick one that is one of the 6 properties we've talked about that always has to be true. So first of all, A says, is AC, is this diagonal always congruent to AD to a side? So do we have any property or rule that says the diagonal in a parallelogram is always congruent to one of the sides? No, we don't. So cross that one out. We're looking for something that's always true. Do we have a rule or property that says that triangle ABC will always be isosceles? No, so it can't be that one. Cross it out. All right. Do we have a rule that says triangle ACD will always be an acute triangle? No, we didn't have a rule that said that either. That means it's the bottom one. That's the property I had you write in your notes when we first started talking about parallelograms, and it's also the property I just had you add to your quadrilateral cheat sheet, okay? This says that triangle CDA is congruent to triangle ABC. We found out that's always true. If the diagonal is drawn, it breaks the parallelogram into 2 congruent triangles. This is yes. This is the correct one. So you would pick D as the correct answer, okay? Does that make sense? Okay. Always get 2 congruent triangles when you draw the diagonal in a parallelogram, all right? All right, number 2 down here. Which of the following is a counterexample to the statement below? Now, a counterexample is like an exception to what the statement is. Okay, can you find an exception that proves the statement isn't totally correct? Okay, that's what a counterexample is. Something that shows the statement has a flaw, that it's not quite correct. Yeah, Trina? Okay, so you think it's C. Close, but not quite right. We'll talk about why. Huh, what, Trina? Nope, just let me help you with this, okay? So we've got these 4 quadrilaterals. Because we're looking for a quadrilateral that has perpendicular diagonals. It says if a quadrilateral has perpendicular diagonals, then it's a rhombus. So what we're looking for, is there a quadrilateral with perpendicular diagonals that's not a rhombus? You see, that would be an example that proves that statement has a flaw to it, that it's not quite right. Okay, so if you can find a quadrilateral that has perpendicular diagonals, but it's not a rhombus, then that would be the correct answer here. Okay, so let's first of all go through these. Now, when you take the test, they won't have diagrams, I don't think. I think they'll have some kind of wording. But I thought the diagrams would be helpful today. But you do have your little cheat sheet to look at to remind you, okay, what's going on here. So first of all, what kind of a figure is A? What does A look like? It's a rectangle, right? What does B look like? It's a rhombus. What is C? It's a square. And what's D? It's a kite. Now, if you had pictures, which I don't think you will that day, but if you did, remember, one of the things you can do is just take a piece of paper, and if the diagonals are perpendicular, the corner of that paper represents a 90-degree angle, it would be a perfect fit. So you can see that the kite does have perpendicular diagonals, plus we just talked about that. It's on your cheat sheet. You can see that a square has perpendicular diagonals, plus it's on your cheat sheet, right? We just talked about the square. You can also see that this rhombus has perpendicular diagonals, and that was on your cheat sheet. And then, if you check the rectangle, notice that piece of paper does not fit in there perfectly. Where I've got it, that angle is bigger than 90 degrees, right? And this other angle next to it is smaller than 90 degrees. So the diagonals are not perpendicular in a rectangle. Remember, we're looking for a counterexample. We're looking for which one of these shows me that there's an exception to this statement, that this statement is not quite true. Because the statement says if a quadrilateral has perpendicular diagonals, then it's a rhombus. So which one of these has perpendicular diagonals, but it's not classified as a rhombus? Well, you know it's not a rectangle because the diagonals aren't even perpendicular. You're looking for something with perpendicular diagonals that's not a rhombus. So it's not a rhombus. Do you see that? You're looking for something with perpendicular diagonals that's not a rhombus. So am I going to be talking about a square, or am I going to be talking about a kite? I'm going to be talking about a kite is the correct answer, because what is a square technically also? A square is technically also what? A rhombus. So you see why you can't pick rhombus? So rhombus, you can't pick it because technically it is a rhombus. It's both a rhombus and a rectangle, so it would not be a counterexample. The only correct choice here is D, because it is a quadrilateral with perpendicular diagonals, but it's not a rhombus, okay? Do you see why it's a kite? You guys okay? All right. All right, moving on. Number 3. Which description does not guarantee that a quadrilateral is a square? So basically, you're looking for which one of these definitions does not guarantee you get a square. So, A, if my quadrilateral has all right angles and has all sides congruent, does that give me a square? Yes, that gives me a square, right? So I'm looking for the one that does not give me a square, so that doesn't work. That's not the right answer, because that would give me a square. What if I have a quadrilateral, all sides are congruent, and all the angles are congruent? Is that a square? Does that work? Is that a square? Yeah, that's also a square. So I don't want that one. I'm looking for the one that's not a square. I'm going to jump down to D. What if you're told it's both a rectangle and a rhombus? Does that guarantee it's a square? That's the one I've been trying to hit home with you. Yes. If you're told it's both a rectangle and a rhombus, that guarantees it's a square. That's the only one that has that definition. Okay, that means the correct answer here, the one that does not guarantee a square, is C. That says if the quadrilateral is a parallelogram with perpendicular diagonals, that would only guarantee it's what? It's a parallelogram with perpendicular diagonals. If you look on here, here's a parallelogram with perpendicular diagonals. Do you see that that would just guarantee it's a rhombus? You don't have enough information to guarantee it's a square. This would only guarantee it's a rhombus, so the correct answer is C. Okay? Alrighty, number 4 here. In the diagram below, parallelogram ABCD has diagonals AC and BD that intersect at point E. Which expression is always true? All right, so let's go to each one of these. So first of all, it says angle DAE, well, DAE would be this angle here. Is DAE going to always be congruent to angle EAB? Well, this would be angle EAB. Is there anything that tells us those two angles will always be congruent? No, we didn't learn anything that says in a parallelogram those two angles are always congruent. So no, this is not always going to be true. Okay? Next one, angle ADC. ADC, that would be this big angle here. Is it always going to be congruent to angle DCB, this angle there? I don't know how to distinguish them. So just there's red angles and there's blue angles. Let's just focus on the two blue angles right now. Is there any rule that says this big angle ADC is congruent to this big angle over here with the 3 blue arcs on it, DCB? Is there anything that says those two angles are going to be congruent? No, in fact, they're going to be what? Instead of congruent, they have to be supplementary. So that was a big fat no. All right. Now, we're done with angles. Okay, so now, in just any old parallelogram, is there a rule that says diagonal AC is congruent to diagonal DB? Is that true in parallelograms? Not in all parallelograms. It's only the diagonals are only congruent in what kind? Which ones? This is no, because it only happens, remember, let me refresh your memory. The diagonals are congruent in a rectangle, remember? And if they're congruent in a rectangle, they're congruent in a square. So they're not congruent to each other in a parallelogram, okay? The only thing you can say about the diagonals, let me get closer over here. The only thing you can say about the diagonals of just any old parallelogram is that they bisect each other, remember? The only ones that they're congruent in would be a rectangle and then a square, because a square is both a rectangle and a rhombus, okay? So this last one is DE congruent to EB. This one will make sense if you get all the way down to this one, and that's because DE is this piece here, and it's going to be congruent to EB. Remember, the diagonals bisect each other, so these two pieces are congruent, and those two pieces are congruent, so that's the one that's correct, okay? Because the diagonals bisect each other, okay, in all parallelograms. All right? Okay, any questions on that? All right, let's flip this over. All right, so the back side of this. Okay, now we've done some work on these trapezoids where you have to find this right here. This is called either the mid segment or the median. Okay. And what happens on a trapezoid, you have the two sides that are parallel, they're called the bases, And these two other sides that are not parallel, they are called the legs. And if you find the midpoint of each leg, if I find the midpoint of that leg, and then if I find the midpoint of this leg, and then I draw that segment in, you get the mid-segment. Okay? So there is a pretty cool property where this mid-segment, or median, it not only ends up being parallel to those two bases, but it ends up being the average of the two bases. Remember that? It's the average of the two bases. And when you take the average of two numbers, it means you get a number that's smack in the middle of the other two numbers, okay? So how do you find the average of two numbers? Yeah, you just add the two numbers together and divide by 2. So if I take 20 plus 12 and add those two together, I get 32. And then once I add them together, if I divide by 2 after I add them together, then I get my average. So the answer to this is 16. That means the length of this is 16. Remember I said you'll get a number smack in the middle of the other two numbers. Notice that 16 is 4 bigger than 12, and 16 is 4 less than 20. It's directly in the middle of the two numbers, okay? So that's a way to tell if you've done it correctly. You should get a number right in the middle of the other two, okay? All right, any questions on that? Okay, and notice it's always bigger than one number and smaller than the other one too, because it's in the middle, okay? All right, number 6, determine whether each statement is always true, sometimes true, or never true. So, the diagonals of a rectangle, are they always congruent, sometimes congruent, or never congruent? The diagonals of a rectangle, is it always true, sometimes true, or never true? Yeah, diagonals of a rectangle are congruent. They're always congruent. That is a property of rectangles. So this is always true. Okay, the diagonals of a square are perpendicular. Are the diagonals of a square going to always be perpendicular? Yes, remember, because it's both a rhombus and a rectangle. So the rhombus is perpendicular, so the square is too. So this is always true. The diagonals of a rhombus are congruent. This one's a tricky one. Okay, so we know for sure that the diagonals of a rhombus are perpendicular. Are they ever going to be congruent? Which situation could they be congruent? How about when the rhombus is a square, right? Because the rhombus is both a rectangle, the square is both a rectangle and a rhombus, and since the diagonals of a rectangle are congruent, remember that means that you get the diagonals of a square will be congruent. And since a square is technically a rhombus, this is sometimes true. Because it only happens when your rhombus is a square. All right. The diagonals of a parallelogram are perpendicular. Now, is that true of all parallelograms? Are the diagonals of all parallelograms down here, are they always perpendicular? No, right? All we could say about the diagonals is that they bisected each other. But remember, the rectangle, the square, and the rhombus are also parallelograms. Are they perpendicular in any of those? Yes. So that means the diagonals of a parallelogram are perpendicular sometimes. In other words, if my parallelogram is a rhombus or a square, then it'll be true. But it's not true of all parallelograms, okay? So that's how you would answer those. Okay, so now, quickly, this Venn diagram is kind of a way to think about the similarities and differences of a rectangle and a rhombus. And we're going to do that in particular. That's what I want to do. Rectangle and rhombus. We're going to compare them and contrast them. So we'll first of all talk about the rectangle here in this circle. We'll talk about the rhombus in the other circle, and then I'm sure you've worked with Venn diagrams before, right? And so this part where it overlaps, what's that going to apply to? What would be, yeah, the stuff that's the same, that is in both a rectangle and a rhombus, and which one of those is both a rectangle and a rhombus? A square. So this will be the stuff that's both a rectangle and a rhombus. It will apply to a square in this one. So for a rectangle, now we'll put rhombus over here. Well, first of all, I'm going to go quickly. I'd normally have you help me, but they're all parallelograms, right? So a rectangle is a parallelogram, a rhombus is a parallelogram. So if it's both a parallelogram for the rectangle and rhombus, it's a parallelogram also for a square. Okay. Now, one thing that's important about a rectangle is that it's got 4 right angles, right? You can say it has 4 right angles or it has 4 congruent angles, right? Either way. A rhombus has 4 congruent sides, right? So that means a square has both 4 right angles and 4 congruent sides because it overlaps both of those. So this has 4 right angles and it's got 4 congruent sides. Okay. And then the other thing we can say is that it has the rectangle, its diagonals. The diagonals are congruent. And then in a rhombus, the diagonals are perpendicular. And so we'll put down here the diagonals are upside down T means perpendicular, and then I'll put the congruent symbol. So the diagonals are both perpendicular and congruent for the square. Okay. All right, now I want you to put your name on this, and I'm going to come collect it from you. And I will let you look at this